Hello, and welcome to our FileCatalyst December webinar. With webinars, I usually try to do them a bit late towards the end of the month instead of earlier in the month, but since Christmas break is upon us, we're going to be doing it a bit earlier this month. So thank you all for attending. We have a good group to this month as well as pretty much all the other months as well, so it's looking good. And I just wanted to mention a couple of things. If you do have questions, feel free to type them into the questions box of the GoToWebinar interface. And at the end of my presentation, which should take about less than 30 minutes, I will go through your questions. Also, another thing I wanted to mention, that this presentation, I was lucky to be invited by Oilcom organizers to present a keynote at the last Oilcom, which was about a month ago in Houston. So I figured this material is very good, and I figured that I'll do a webinar based on it. Of course, changing a few things, but mostly keeping it intact as the way it was at Oilcom. So thank you for coming. Again, my name is John Tkachevsky. I'm the co-founder and president of Unlimitech Software, the makers of FileCatalyst products. So we'll be talking about, we're a file transfer company. This is all about really talking about how we can move big data in created by the energy sector, and how you can move it and manage it better. So the big the big data, you have to think of it before I even get into how we can move it and how we can make it faster and all this stuff. I just wanted to go over why there is big data in the energy sector. So some of the big data comes from, first of all, exploration. That's probably was one of our biggest. We've noticed in the last 2-3 years a great increase in the number of clients from the energy sector licensing our technology, our acceleration technology, and we've been asking them what they are using it for and how they're using it. And I would say probably predominantly they are using our technology for the exploration data. So when you're actually doing the early exploration and trying to figure out where you're going to dig, drill. We have some clients also doing drilling and retrieving data through drilling, or there's also some production data coming through that could be like, video surveillance videos, monitoring equipment generates data. But that's a little bit more of a secondary thing. But the biggest data generator is usually exploration and drilling. I'm going to talk a bit about data supply chain. So, like, once we get this big data, what happens to it? Where does it need to go? I just want to, of course, every company has its own workflow attached to this data that they gather. But just wanted to generally talk about that, and then talk about a case study. One of our clients that is using our software for exploration and moving big data between London, Houston, and Malaysia. So one thing we have to, where does the big data come from? Well, it's besides of pulling, oil, we're also pulling a lot of zeros and ones, really. That's what you can do. So you're generating data, especially when you drill. And then once you're finished drilling and you're actually doing the production, well, then there's also a lot of data being generated. So this is one of the reasons where the big data comes. There's that whole internet of everything, and there's also the digital-driven oil fields where everything's connected to the internet. All of this generates quite a bit of data. Another place where the data comes, it's on the exploration side. So imagine you have an exploration vessel looking for exploring the ocean floor, and that generates a lot of zeros and ones. And once again, we have to figure out how this data can go from that ship to land. Do we wait until the ship comes to port and we can connect it to a good internet connection, or Do we send, do we just ship a hard drive? Anyways, those are the questions we're going to have to ask ourselves during this webinar here. So, so here are some of the activities in oil and gas that generate big data. So, of course, there's the LWD and MWD. Imagine a device that is hooked up to a drill bit, right behind the drill bit, that gathers a lot of information like your hole size, your rock analysis, your density and porosity of the rock. So all of this data is attached to right behind the drill, and really the difference between LWD and MWD really sends data in real time back up to the surface. LWD gathers this information into storage, into drive storage right on the device itself, and then when the drill bit comes out, you can look at it. So this, helps companies to the operators to drill and decide how far to go, whether to make a turn, for example. All this stuff can help out. Some other exploration information we get, it's reservoir simulation, seismic analysis, fluid dynamics, and another one that very often is overlooked, but it's also quite a big generator of data, is actually the engineering drawings and construction drawings. So when you're building a new site, you're going to have quite a few engineering construction drawings, and to build this, you will need to be transferring these big files, blueprints basically of whatever you're constructing. So all of this creates big data in the energy sector, and we try to we try to solve all these problems by providing some kind of providing a better utility or better tools to move this data efficiently around the world. So we get all this data from all these sites, and what do we do with it next? What happens next? Well, first of all, the biggest problem is that if you want to do any kind of analysis, simulation especially, you will need a data center or high-performance computing centers. Data centers, unfortunately, are not in the remote locations where we're drilling or exploring. So you cannot build a big data center in the middle of the Atlantic or the North Sea. So what you have to do, you have to take this data and move it somewhere the data centers are. The data centers are usually located where the major population is. So your big urban centers, and you will usually the data will have to end up there for any kind of analysis and simulation, just because the cost of building a data center on the rig is way too prohibitive. So here's the first problem, that you need to move this data. The other problem is that once this data goes into your data center and you can actually do some analysis and simulation and interpretation, you're going to have to move. You have to then provide this compiled data, or modified data to your stakeholders. So it could be your customers, could be the owners, could be potential people that will be actually doing the production on it. So all this data then has to be distributed, and everything today is worldwide. So your distribution of this data also becomes important. So this is really what happens. You collect the data, you move it to a data center, and then you have to move that data again to some of the stakeholders of what you're trying to do with the project. So option one, which is I think still used a lot today, is to ship hard drives. And when you ship a hard drive, well, there's two things. First of all, there's the shipping cost. There's the shipping cost required to ship the hard drive. Second of all, it's not really in real time. Well, if you're going to wait until the ship arrives to port, and then you have to package these hard drives up and ship it, well, then you're wasting a lot of time. Same thing, what happens if those packages get lost, or if data is corrupted on one of those hard drives. Well, now you have to resend another hard drive, the one that failed. So the process is slow and long, but it's still used a lot in the industry, and this is really what we're trying to address, is to move away from the case with hard drives being shipped around the world. So we could use the internet, and this is what the modern oil companies are going for. They're saying, shipping hard drives is expensive, it's not reliable, it's slow. So let's use the internet. So, we start using information like FTP. You can send email, attach some files. You can do a file sharing site, or you can use, a cloud service, or just use Windows folder, Windows directory sharing or folder sharing, CIFS. So you just you create yourself you want to somehow transfer this data over. So all of these are working. The only problem with all of these information is that they still will be slow. Even if you use if you have a good FTP site and good bandwidth, if you're transferring data from one continent to another, all of this still will be slow. So sending big data in the energy sector, I really see it as twofold problem. There's the last mile problem. So this is your connections to the rig, to the vessel, to the oil platform, to the drilling site. All of these are remote locations. They usually have a very poor connectivity. It will be a satellite connection. It could be an L4G, 3G, maybe microwave with a line of sight. But these are all slower bandwidths, very unreliable, and that causes a problem for any kind of file transfers. Second problem in big data is really sending the information between big data centers. So the data gets to the big data center where it gets processed, and then it has to be moved to another big data center for example, to another stakeholder. Well, there you have very big fat pipes between these data centers. You might have 100 megabits or maybe even a gigabit. But the problems there, you have locations that are really far apart. So for example, a lot of our clients move data between Houston and London. It's a long distance. That distance causes any file transfer to be very slow, even if you have 100 megabit or a gigabit connection between these sites. Everything still will be very slow. So the traditional file transfer methods, as I manage, cloud, FTP, email, this will be slow. And why is it going to be slow? Because transferring a large 10 gig file between London and Houston will still take several hours with all these tools. And why are they so slow? Because of the two factors on the network. And this applies both for the last mile as well as the big fat pipes, that there is a latency on the network and you're going to have a packet loss on the network. So latency is the delay. So imagine if I want to send a packet of data between Houston and London, that takes about, I would say, 150 milliseconds. So this delay causes the slowdown in the file transfer. And same thing goes with the packet loss. Once again, the packet loss on the big fat pipes is probably very minimal. On the internet, as an average, I think it's less than 1%. So it's a fairly low thing. But on the last mile links, packet loss could be easy, a 5% or a 10% as the norm. So there you have, more of a packet loss, and also the latency will also play the role. So what happens is these two things really slow down these transfers. And why does it slow it down? Well, we have to now go back way, way deep into the networking world and talk about TCP, the Transmission Control Protocol. It was built in the 70s. Without it, internet wouldn't exist. It powers basically everything you do on the internet today. It powers HTTP, FTP, SFTP, SMTP, CIFS. Any protocol on the internet uses TCP. The TCP provides reliability, error checking, make sure that the networks the packets arrive on the network in the correct order. It has congestion control built in. That means it will share and slow down if other applications try to use the network, and basically nothing could work without it. But TCP was never designed to move the amount of big data, and was never designed in the era when we have when we have the big fat pipe connections. So TCP gets affected by the latency. So here's why latency slows down the TCP transmission. The concept is fairly simple. When the TCP wants to transfer a file, it grabs a chunk of data and moves it over the network to the destination. Once that chunk of data arrives, the receiver then has to say, yes, I got it. Once the acknowledgement comes back to the sender sends the next packet of data. So what happens is that there's very little data on the go on the network. And this creates that dead air where there's nothing being sent because you're just waiting for the acknowledgements, waiting and waiting for the acknowledgements. This illustration only shows you how latency really works, but if you want to imagine, I really like this example that let's say if you want to send files from Europe to Australia. Well, you'll be looking at a latency of about 1/3 of a second or 300 milliseconds. I'm not exactly sure what's the packet of data on TCP is these days. This is something that is tunable, but it's in a range of, let's say, 100K. So imagine every time you send 100K of data to Australia, you have to wait 1/3 of a second before you send the next packet of data. So what happens, it doesn't matter how fast your pipe is, you'll never be able to maximize it because every time you send 100 kilobytes, you have to wait 1/3 of a second to send the next chunk. And that will cause that slowdown that I'm talking on TCP. Another illustration also I'm not providing here is what happens with packet loss. And the packet loss, as I mentioned on the last mile, is probably a bigger issue. The packet loss with TCP notices any packet loss on the line, it literally takes a packet of data and chops it in half. So instead of sending 100 kilobytes, the next time around we'll only send 50 kilobytes. And then we'll slowly build up again to a full 100 kilobytes if there's no other packet loss. If there's another packet loss, then once again it will cut it in half. So every packet loss event in TCP causes basically the speed to drop in half instead of just continuing, because packet loss on some networks, especially satellite, is a very common occurrence. You can't really slow down this by this much because this is just something that happens. So when we use FileCatalyst, we actually transfer our files using UDP. UDP is also a protocol. It's a cousin. It's a close cousin of TCP. It's probably designed in the same time as TCP. UDP, you have a lot of benefits of it. First of all, you can send data continuously. You don't have to wait for acknowledgement. You can send data as fast as you want. You don't have to wait for acknowledgements. But TCP, on the other hand, is not reliable and doesn't have really a good rate detection. It's not fair, so it will always use up all your bandwidth. So what we did with FileCatalyst, used the UDP protocol, and we've built all this stuff that TCP has, but it's friendly for big data. So if you're sending big data, we will actually slow down and share the link properly. We will make sure that the rate that we're sending at the rate that is maximizes your bandwidth. And because we don't wait for acknowledgements for every packet, we can send data continuously, and then only the exceptions or only the errors are acknowledged. So imagine receivers sending data, senders picking up data, and then the sender is going to just raise its hand and saying, sorry, the receiver is going to raise its hand saying, I didn't get packet 7. At that point, the sender is just going to go grab packet 7 and resend it. And this is what so UDP is really just the transport. All the smarts and all the intelligence of how this is done is actually built into the FileCatalyst product. So this allows you to speed things up. And the acceleration is actually quite phenomenal. So as you notice here, this is a table for FTP versus FileCatalyst. This is a gigabit connection between Alberta and Houston. You can see with FTP, a 10 gig file can take 7 hours to transfer. With FileCatalyst, this will take 1:25. here's another example that is a little further distance. Now you're looking at Stavanger to Saudi Arabia. Now you want to send a 10 gig file. You're looking at, over almost 17 hours with FTP, and we're still at minute 25. So what really this graph you should remember from it is that you look at this RTT here. RTT is 70 milliseconds, FTP is 7 hours 45 minutes. RTT is 150 milliseconds, FTP 17 hours. While FileCatalyst has always a minute 25. So it doesn't matter what RTT you give me or you ask me to provide you the number with, you will see that FileCatalyst will always be a minute 25 versus FTP will change quite a bit. Now, if we go in a perfect world and we say RTT is 0, meaning that I have two computers side by side, I want to transfer files, FTP will most likely be in that range of, a minute 25 to 2 minutes as well. So in a perfect world, FTP can actually deliver the same speed as FileCatalyst, but unfortunately we don't live in a perfect world, and latency and the delay on the network exists, and this is why we created FileCatalyst in the first place. So some of the options that you might want to consider when you're looking at an accelerate, creating a proper data mover or a big data moving strategy for your company. So companies have looked, the one optimization hardware. So this is, your one optimizer have existed for years. That's one option. You can look at our commercial off-the-shelf file transfer acceleration software. So FileCatalyst, for example, that's what we do. Or you can look at some open source solutions. So I just want to go through them quickly here, give you an idea what you're looking at, and some pros and cons. So one optimizer, the biggest benefit there, it's a hardware box sitting between 2 points, and it optimizes all the traffic. So regardless of what it is, it will optimize everything, including your FTP traffic. It is a hardware solution, so you just plug it into your rack and it works. Some cons, it is a hardware solution. You need to ship a box wherever you want to optimize the transfer. You need to be able to maintain that hardware, and it's it is you're confined to wherever you have the box, and you have to still set it up and provision it. The cost right now, you're going to be looking at the hardware cost for every node where you want to accelerate to. You got to buy a box, and you don't get any file transfer tools. So for example, if you go with a software solution, you will get file transfer tools for automation, for doing rsync, for doing for monitoring and notifying you if things go wrong. In this case here, you're just using plain Jane FTP over one box or one transfer. So if your FTP server runs out of the disk space, you will never be notified that this happened, because that's not the point of the box. The box notifies you will notify if the link drops, but that's about it. Here you'll be able to have much more better detail what's going on if your file transfer fails. And then you can also very quickly log in and manage the entire system as well with a software solution. So COTS, as I mentioned, that's what we do with FileCatalyst here. So you have a flexible software-only deployment. You need to accelerate moving content into a new location. Well, it's just a matter of downloading one of our software packages, so quick setup, and then you can transfer files. We provide you all the tools that an enterprise would require to move big data, so monitoring, management, automation, command line, scripting, APIs, all of these tools you get with it. And we can also provide you web applications. So if you want to, accelerate file transfers on the web browser, well, with a hardware box, I think it's quite impossible to do that. But with a software solution, we actually have a number of web interfaces that you can actually deliver files directly to a web browser. It's definitely, it's not free like the open source, but it's definitely less expensive option than hardware. And it is limited to file transfers only. So if you are looking for accelerating, SQL calls or browsing or anything like that, that's not that will not do it. And there is some configuration required, especially in the very beginning when you're setting up your server. But even with the one optimization, there's also configuration required. So, but this is some of the things. So some of the open source stuff, I do have a nice blog where I'm kind of comparing the open source accelerated file transfer solutions. Take a look at it later on if you want. Just go to our blog site. It's free. It has also the flexible software deployment. But a lot of these packages are, for example, don't adapt very well for changing network conditions. So if you're transferring files and you all of a sudden need the link to do something else, well, you don't have room, because the application is not going to slow down to allow something else through. There's no tools, no advanced tools. I'm not even talking about here like a GUI client like FileZilla. I'm talking here about command line tools. You don't even have command line tools. A lot of them just come as an API that you have to build yourself to do something else. And there is quite a bit of configuration required, because since not everything is adaptable, nothing's adaptable to network conditions. You got to figure out what speed you want to start and how to transfer it. And another issue is the packet loss. If you're in a big packet loss scenario, a lot of these solutions will not work properly. But once again, it's free, and if you have plenty of time and you have a very limited functionality, maybe that's something you can do. So some other if you're considering moving to an accelerated file transfer within oil and gas, here are some of the other things that you should be looking at. Make sure you look at a solution that plays fair with other network. So you don't want your VoIP or your web browsing to die when you're transferring files. It's understandable it's going to get slower because we're using the bandwidth, but it should not die. Make sure, check what's the top speed. If your project requires you to a gigabit implementation and you look at a file transfer solution that cannot do a gigabit, well, then maybe that's not the right vendor for you. We can work up to 10 gigabits, and so this is something we regularly test in our labs, and our software can deliver, links up to 10 gigs without a problem. Make sure, especially in oil and gas and you're doing last mile, make sure you have something that works with packet loss. You can easily download or even purchase a network emulation hardware. So it's a box that will emulate wide area network connections, and you can test this stuff. You can test your packet loss on these links. You can test latency. It's a good tool for these type of applications, especially if you're considering a file transfer application. Well, if in oil and gas, there's also a lot of you not always send very big files, one big file. Very often you have thousands or hundreds of thousands of small files to send. Well, our solution is optimized for that. When you're doing a transfer, it's very expensive to open up a socket, negotiate a connection, and then transfer one small file that is 3 KB. It takes usually longer to do that than actually transfer the file. So you need some solution that can optimize this. So what we do actually in the background, we will create a big archive or a big chunk of the small files and send all the small files in one go, and then decompress them on the other side to provide you that better added performance if you're handling a lot of small files. We've seen performance improvements, probably fivefold to on top of our acceleration technology for small files. Make sure you have automatic retries and resumes so that file transfer can automatically resume from where it last stopped. That you have security, you have reliability, meaning that there will be a guaranteed delivery or the type of mechanism. So after the file is delivered, you can do a bit-by-bit comparison checksum, and only if that passes, then the file is deemed delivered. So that's called a guaranteed delivery. Make sure you have automation tools, APIs, management, central management of all of this, so you can actually see what's going on with your file transfers. And finally, look at, especially if you're sending data that you've sent before, then you have rsync built in. So for example, you send a 10 gig file, but only on the next version of that file, only a small piece changed. What we will do an rsync and only send the deltas, the difference. We will not send an entire file all over again. So this is all built in and transparent in our FileCatalyst protocol. And these are some of the issues you should be looking at when you're looking around and evaluating file transfer solutions. So to the case study, some of the this is our client. They were a marine exploration company. They have a fleet of ships going around the world doing marine exploration. And these multiple ships need to deliver data almost in real time to London, to their high-performance computing center, where the analysis can be started. And then finally, once that analysis is done, then all this data needs to be delivered to the major markets. And the markets are in Houston and Malaysia. So here you have the problem. The first, the ships is your last mile, then you have your data center, and then you have your data center to data center transfers, as I mentioned before. Before they started using our software, well, data from the ship was not even deliverable. Everything they had to wait for the ship to arrive in port, grab a drive, ship it. And even the final data deliveries, the data used between data centers and data centers was taking hours, and sometimes they also had to ship hard drives. So FTP was not usable definitely for the last mile, and for the data center to data center final data delivery was taking very long as well. So here's sort of an example how this has all worked. You got your ships going around gathering data. They usually had a satellite connectivity. Everything was delivered to London, wherever the data was analyzed, simulated, and then the final results had to be delivered to either Houston and Malaysia. And here you had the big fat pipes, and over here you had the smaller pipes. So what happened? Well, they seen more control over file transfers. First of all, they were able to see exactly a big speed improvement, and they were able to control exactly what transfer is going at what speed. And because that's another thing with the acceleration, you can actually in real time control the speed of your transfer. So if something is less important, you can slow it down to give your bandwidth to other transfers. The 10 gig line between London and Houston was finally maximized, and they were able to use the full extent of that line, which I'm sure it's getting a 10 gig line is a pretty it's a pretty big venture. So not being able to maximize it was a big plus for them. Made that the file deliveries to clients made it very simple and straightforward concept. There was no more guessing what to do, and the end user for both clients and back office processes and staff dramatically improved. In this case, we helped out a lot in the on the deliveries from the beginning to the end, and also the internal deliveries in the back office as well. So I'm almost finishing up. I think this is my last slide. Just to give you, so where are we going from here? What's going to happen down the road? Well, I think the big data in energy sector and energy mining, natural resources sector is just going to get bigger. I can see people want to have more information, more high definition stuff. Everything is going to get, this data is going to get bigger. The connectivity is going to definitely improve as well. 4 years ago, and standard ship-to-shore connection was maybe 128 kilobits. Today, almost everyone is on 256 kilobits, and 512, or even the high-capacity satellites are coming out right now, where you're going to have, several megabits of upstream from these newer satellites. This is all hitting the market right now. Unfortunately, latency will remain where it is. Why? Because we cannot make speed of light go any faster, and that the only way to improve latency especially for satellite links, well, it's to come closer to Earth, and then you're going into into a non-geostationary satellites, which have lower latency, but then the problem becomes how to track all of this so you can have always good speed of transfer. So those solutions are very expensive. A software solution, on the other hand, that can deal with latency properly, and you can continue using the geostationary satellites, is a lot less expensive. There will be new technology. So, the big thing is that whenever you have a bigger network pipe or faster computer or more memory, some techie out there will come out and figure out how to fill it. And this is not any different in the oil and gas exploration and mining. As soon as you provide the bigger pipes, the faster computers, there will be a new application that will make things a lot easier to extract or to explore, and that will take up more bandwidth and more computers. So that's how usually technology grows. That you get faster computers, well, you get smarter applications, but then you get more data, and you need more connectivity, and everything the ball just keeps on rolling and getting bigger. The snowball just gets bigger and bigger. So this is where I see in the future, is that all of this will, go up. Unfortunately, latency will not change. Maybe in 100 or 150 years, Albert Einstein 2.0 will be born and figure out how to do things faster than the speed of light. But for now, this is something that stays, and this is what will make our, especially our file transport technology relevant for the years to come. So thank you very much. I have a few minutes for questions. And thank you once again for attending. And I'll have the recording of this webinar available on our website and on our YouTube channel shortly. And come and visit us. We have webinar every month. Usually it's towards the end of the month. So my next webinar will be somewhere in end of January if you're interested in listening. Thank you very much for attending. I will take some questions now.